Alright, very quick video here on how to find Extrema using a graphing calculator. In a subsequent video I'm going to go through this process with a little bit of calculus, but for right now let's just kind of introduce this idea of Extrema and show you what they are and how to find them using our technology. So when we say Extrema, you can see that it has sort of a root word in there of extreme values, right? So we're talking about minimum values or maximum values. Now we usually talk about them in terms of locality. So this one right here is local. It's a local minimum, meaning it's lower than all the points that are sort of in its neighborhood. It's not the lowest value because there's one over here that's lower. This one up here is what we would call a local maximum. Sometimes we see them called relative instead of local relative maximum, relative minimum, and that just means that it's sort of taller than all the other points that immediately surround it. And there's a really quick way to find those values using our graphing calculator. So let's go through that right now. And what I want you to do is type this into y sub 1, and when you do that you're going to get this graph. Alright, and our job using our graphing calculators is to figure out these two values. So we go second trace, which gives us the calculate menu. Then I go to minimum. Let's go down to the third option. And my cursor is blinking right here and it's asking me for a left-hand bound. So I'm just going to click left a little bit so I'm a little bit to the left of that minimum value. I press enter and then it asks me for a right-hand bound. I press to the right until my cursor's on the other side of the minimum value. And I press enter and it says guess. So I just get it as close as I can and I press enter. And sure enough, it shows us that the minimum is at 0, -3. And we can see that it's not super difficult for this one, that you can see that the minimum value is 0 and -3, the local minimum or the relative minimum. This one's not so clear, I don't think. It looks like it's somewhere, we're talking decimals here, so we got to figure out the x and the y coordinates of that max value. So go back to your calculators and press second trace, which gives the calculate menu. We of course want the fourth option now, which is maximum, so I'm just going to press 4. My cursor's still down there. It wants to know my left hand bound, so I just need to be somewhere to the left of my maximum. You could have pressed enter at the start, but just to show you that if this is our maximum, we just want to be slightly to the left of it. I press enter. This gives our calculator a place to sort of look. Right hand bound, just get to the right of that mountaintop, and then press left and get it pretty darn close to where we actually are looking for. And we can see that we get 2.6 repeating, comma 6.48. 2.6 repeating, comma 6.48. And that will be considered our local or our relative maximum. Alright, now there's a lot more theory behind this, which we'll get to in a second. Right? We'll talk about we'll talk about the first derivative and how the values right here are all decreasing and then it switches to increasing. So our first derivative here will be negative and then here it'll be positive, and then once it starts decreasing again it'll be negative again. So anywhere that the first derivative test yields a difference between a plus and a minus, that's where we're going to have an Extrema point, a point of Extrema. It goes from minus to plus, of course it's going to be a minimum value. So we'll talk a little bit more about the theory in a second, in our next video but for right now that's pretty much it. Finding Extrema using our graphing calculators. I'm not going to go through another example. If you want to rewind that, go for it, but I hope you enjoyed this video and thanks for watching.